All right, completing the square is going to look something like this. I'll have f of x, and I'm going to notice I don't want that 2 out front, so I'm going to factor it out. So I'm going to have 2 times x squared minus 2x, and then I'm going to leave that 18 alone. That 18 has nothing to do with me completing the square. I really care about this, and then everything else goes along for the ride. All right, let's complete the square. So that's going to be 2 times x squared minus 2x plus something, and that something is going to be b divided by 2 squared. Then we have that plus 18 on the outside, and since I added something, I do need to subtract it, and I need to subtract away that negative 2 over 2 squared. However, this is the hardest of the problems because we have that 2 up front. And since that 2 gets distributed there, we have to not forget about the 2 here. So that's going to give me 2 times completing the square would be x. What's inside the parenthesis is negative 2 over 2, so that's minus 1 squared plus 18 minus, well, negative 2 over 2 is negative 1. Negative 1 squared is a positive 1. 18 minus 2 is going to be 16. My vertex is 1, 16. Not negative 1, 16, but positive 1, 16. Yes?
How would you get x minus 1 squared?
That's what completing the square is. You put this number in here so I can pull down the x and whatever's inside this parenthesis. That is completing the square.
And why is this completing the square different than the one we did with 2 checkers?
It is exactly the same. The only difference is I can't work on both sides of the equation because I do want y equals at the end. So the only difference is I don't move. So the other way we did this was I'd subtract 18 over here and go from there and divide everything by 2 or something. But I don't want to do anything to this side because I want it to remain y. So we're doing all the same steps, but we're keeping it all on the same side so that my y stays on the left-hand side. Yeah?
So the vertex formula thing, it says like plus k. So then like if that 16 had been like negative, would it just be like plus like negative 16? So in a sense, like it's like k is just like a negative value. But we write it like minus 16 as like a formality.
What?
Never mind.
Are you saying, let me just, so you're saying that there's a negative sign here?
Yeah, like if it were negative, is it still like plus k? Would it just be like plus negative 16 because that's like the value?
I guess it'd be plus negative 16
would
be a way to look at it.
Because that's one reason I got confused on the homework. So I'm like, but it says plus k, but that was negative. And then
Gotcha. Yeah, if it's negative, then it's just negative 16 because it'd be plus negative 16.
Yeah, okay.
I see what you mean. All right, any questions on this? All right, what questions do we have in the homework? Fatima?
The last one.
What about it?
I feel like I got confused somewhere.
On what part, I guess? Because there's a bunch of parts on
I
it.
don't know. I just know I did something wrong.
Do you know what you have wrong?
For the AOS, I got, it's supposed to be negative 1.
Mm-hmm.
But when I did the vertex form,
Did you get your axis of symmetry being negative 1?
yeah,
Okay. But your vertex didn't come out right?
yeah.
So your vertex, just to be clear, your y value, your x is so to be negative 1 some point, right?
Mm-hmm.
So it should be negative 2 times negative 1 squared minus 4 times negative 1 plus 8, correct?
Mm-hmm. Oh, wait, I figured it out. Thank you.
Okay, is that it?
Yeah.
Okay. There you go. Other questions on the homework? Okay, then we'll go right into today's lesson, and that is solving quadratic inequalities. It's a lot easier than it sounds. We've done this. We've done every part of this. In fact, we did part of this on the test that we just took, which is done, graded. It's in the grade book, but we still have people who haven't taken it. So we're just going to hold on to it. If you want to see it, you can come see it outside of class. It's fine. I just don't like handing them out and collecting them all. And you saw all the answers and stuff with people. Being in here that didn't take it. And what I'm referencing to on the test is we had something that looked like this. And I said, when is it less than 0? And you just kind of shaded in this area. The big mistake on the test was It was just a less than or a greater than. I can't remember. There was no equal to sign, so there shouldn't have been any brackets on it. It should have been all parentheses. That was a big missed problem on the test. But that's all we're doing. That is all we're doing. We're doing the exact same thing. But now we have to do all the work. We have to come up with a graph ourselves. But this is really easy because I just need a general shape of this graph to see what's going on, and I'll show you what I mean. So the question is, solve the inequality x squared minus x is greater than 6. So I'm going to look at my first step. My first step says determine the zeros. And why it says determine the zeros? If I give you x squared minus x equals 6, we can't factor, we can't complete the square, we can't use the quadratic formula until it's equal to 0. So as soon as we're given an inequality, I'm going to rewrite it so that we can solve it. And that means we're going to have x squared minus x minus 6 is greater than 0. So we're going to deal with something we know how to deal with, and that is when I have a 0 on one side and an equation on the other side. All right, now this looks more like something we've done before. So now is where I'm going to solve for our zeros. And I'm either going to factor it, complete the square, or I'm going to use the quadratic formula. I'm going to tell you right now, this one is factorable. This one is factorable, so I'm going to go ahead and factor it. And so what I'm looking at is, I'm getting rid of the inequality for just a second, just so I can graph it. I have x squared minus x minus 6 equals 0. It is factorable, which means we're going to have a binomial times a binomial equals 0. We have x starting out to give me the x squared. Negative 6, I mean, it's either going to be 6 and 1 or 2 and 3. Yeah?
It's negative 3 and positive 2.
It is going to be negative 3 and a positive 2, because negative 3 times 2 is negative 6. Negative 3 plus 2 gives me my negative 1, which means we have two zeros, not possible, they actually exist. We have either x equals 3, and we also have x equals negative 2. So that means our quadratic crosses that x-intercept at negative 2 and 3. And we know the shape of a quadratic. It's either opening up or it's opening down. So what I said we're just going to make a really rough sketch of this graph, and it's going to be all we need to come up with our answer. So a real rough draft of this. Oh, that's a square. That's y. All right. I'm just going to make an x, y. That's my x and y axes. I only really care about the x because I need to cross at 3, so I'll just make 3 tick marks. 1, 2, 3. We know there's a point right there at 3 because that's based upon this x equals 3. And then we have 1 at negative 2. Negative 1, negative 2. I got that guy right there. Now, either my graph makes a nice little smiley face going through it, or it makes a frowny face going through these 2 points. Is my graph opening up, or is it opening down? David?
It's opening up
It is opening up because it's a positive value in front of our x squared. Our a value equals 1. Maybe I'll put that. A value equals 1, which is definitely positive. Positives make us smile, so our parabola will also smile, right?
So you don't need to know the wires?
No.
Okay.
Nice, isn't it? Could we find it?
But
Yeah.
Shouldn't the wait. So you don't have to find like the axis of symmetry or anything?
No. And I'll explain why in just a second. Yeah.
A. How did you get A? Okay.
Ax squared plus bx minus c. So our a is 1, b is negative 1, c is negative 6. If our a is positive, it opens up because positive makes you happy. If it's negative, it opens down because it makes a frowny face because no one likes a negative equation. It's sad. Yeah. Oh.
How do we know how far down it goes?
Doesn't matter.
Okay, we just have to draw it.
Yep. That's why it's rough. Yes.
So is that the first equation with x squared minus x minus 6 has to be greater than 0?
Mm-hmm.
Is it saying like the ultimate x value has to be greater than 0? Or,
Mm-hmm.
So how can we have negative 2 if that's less than 0?
No, it means when I plug it in, it's going to end up being greater than 0.
Okay.
So if I plug in negative 2 right now, I get out 0. If I plug a 3 in, I'll get out 0. If I plug in a negative 3, I should get out a bigger number than 0 based upon this graph.
So then our solution set would be using parentheses.
It would be using parentheses. Yeah, I do want to bring that up. So rough draft. I don't care about the y values or anything. We'll talk about y. Remember, our end goal is to actually figure out what x squared minus x minus 6 is greater than 0. Well, let's use purple real quick. Everything on this side is where my y... Oh, I just used purple. Pick a new color. Pink? Does pink didn't even show up? Everything on this side is where y is bigger than 0. Everything on this side is where y is less than 0. And right smack dab in the middle is where y equals 0. Do I care where y is less than 0? No. Do I care where y is equal to 0?
No.
Well,
Kind of. But I'm looking for a strictly greater than, right? And strictly greater than means, and several, you should put this in the notes because I would say about 75% of us got this wrong on the test. If there is no equal sign, you use parentheses. If there is an equal sign, you use brackets. And you're all shaking your head, yes, but I'm telling you at least 75% of you got that wrong on the test. I had to cross out so many brackets. So because it's strictly greater than, we're going to use parentheses. And let's go ahead and scribble in where our answer is. Let's use blue. Well, it's anywhere where it's greater than 0, so I'm talking there. I'm talking there. And it would be an open dot if you want to draw the open dots. I usually just scribble now, which means our answer is going to be from negative infinity. So all the way from negative infinity until we get to x equals negative 2. Since it's not equal to, I use a parenthesis. Union that with, well, nothing here, nothing here, nothing here, nothing here, nothing here. Oh, when x becomes 3, it works all the way to infinity. So our finished answer is just that. And the cool thing is, once you have your zeros, a lot of this you can kind of do in your head if you want to. Because you can just go, okay, opens like this, that side's above, that side's above. I can just write that down. Now do you understand why I don't care about what the vertex is?
Yes.
I just care about what's above, what's below, but we could find the vertex. It wouldn't be that bad. Negative b over 2a. All right, we're going to do it one more time. This one, determine the zeros of the functions. It's already set up with 0 on the side, so I don't have to do anything to it. I do have to find my 0 so I can kind of get that idea of what my graph looks like. That's not going to work. I'll tell you right now. This will work. This will work. I'm going to go ahead and use the quadratic formula just because we did completing the square yesterday. We haven't done quadratic formula in a while. Just a reminder, quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the song that goes with it. Or that 2a. Oh,
That's what we knew.
oof. That one takes a turn real quick. Someone dies in that one.
Get stabbed in the head.
Oh, yeah.
That's a good scene.
All right. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's go ahead and fill that information in. So we're going to have x equals negative b, so that would be negative 4 plus or minus the square root of 4 squared minus 4ac, which would be 2 times a negative 9 all over 2a. Trying to remember this. I think it's 4 plus or minus the square root of 88 all over 4. Cool. Let's simplify it. I'm going to simplify it because I can look at that square root of 88 and say, hey, 4 goes into that. 4 goes into it 22 times, so it's the square root of 4 times the square root of 22. Well, square root of 4 is 2. So we can go one more step and go 4 plus or minus 2 times the square root of 22 all over 4. And I'm going to go one step further, and that is to break this apart into 2 fractions. On the test, that was worth half a point. Bonus. That was a bonus point. It's breaking apart the fraction like I did in class. The other bonus point was one of them came out to be in a fraction, and so there was an x value that wouldn't work for it. If you told me which x value didn't work, that was extra credit too. But we're going to end up with 1 plus or minus square root of 22 divided by 2. Real quick.
Do you have to break that into a fraction?
Do I have to do what now?
Break it into a fraction?
I like to. I think that's the most simple. I like the way that looks.
Okay.
But I won't take points off for it. But you do. I would take off points for not simplifying that square root of 88.
That scared me for a second. You said yes, you took off points. I was gonna have to change myself. I was like, oh my gosh.
Oh, don't do that. All right. Jasia. 1 plus or minus square root of 22 over 2. Where is that on my x-axis? Yeah, no. That's the look you should give me. This is probably, because we know we're coming up with a rough sketch of this, and our brains aren't wired to go 1 plus square root of 22 divided by 2. Oh, I know exactly where that is. So what we're going to do is we're just going to come up with decimals. We're going to come up with the decimal version of these to help us.
Between 4 and 5.
Yeah.
It is.
Yes, it is.
The square root of 22.
It's going to be about 3.3. And 1 minus square root of 22 over 2, I think that was 1 negative 1.3, yeah.
Maybe bigger than
Yeah, it's like 3.34. But we're just plotting a point, so I don't care about the hundredths place, I just care about the 10. And in fact, I only really care that it's a little bigger than 3, a little less than negative.
Wait, it's like 2.34.
But then we had 1.
No, it isn't. It's
Oh, yeah.
3.34. Once you add that 1 in there. All right, so let's go ahead and do a quick graph of this guy. A rough sketch is going to look like this. Only care about the x-axes. I need to get to -1, so I just got to go to -2. I have to get all the way up to 3.3, so it's 1, 2, 3, 4. So I have a point at -1.3, somewhere about here, and 3.3, somewhere about there. It's positive, right? We have a 2 up front. That's a positive 2. Positive makes you happy, makes your graph smile. So it's going to look something like this.
Like a cereal commercial.
It is. All right, and just remember, the top side is where y is bigger than 0. The bottom is where y is less than 0. Smack dab in the middle is where y equals 0. Well, I'm strictly looking for where is it less than 0. So I don't care about the equal. I don't care about the greater than. Which means we aren't going to use brackets. We're going to use parentheses. And let's shade in where it's less than. That's anywhere it's underneath 0. So that's this area here. It would be open dots. It's hard to show it when you're shading stuff in. But you should be more concerned about using parentheses. And that's going to be at 1 minus square root of 22 over 2, comma 1 plus square root of 22 over 2. Would I take a whole bunch of points off if you left it in the rounded form? No, I would not. But if you have exact answers, why not give it an exact answer form? Is that super hard stuff?
A little.
Oh, yeah, sorry. I kind of put that in the wrong place.
Oh.
I kind of answered it right there. We actually don't need all the space. I mean, we barely even need to draw the graph because we can just say, picture what it looks like. It must be the bottom part. I hope you do. Meh. All right. The hardest part about this is probably these maximization problems. And in fact, this one's pretty easy. You don't have to do any work. You could probably figure it out. But we're going to pretend like we don't actually know what figure actually maximizes this area. So we have 100 meter of fencing will be used to fence a rectangular region. I want to maximize the amount of area that is used. So I probably don't want to have a super long thing that just has an inch. I want to put as much animal, whatever I can fit in there. So I want to maximize that area on the inside. So it says, express the area as a function of width or length if you prefer. So it really doesn't matter, and we'll talk about why. Let's draw our picture real quick. Let us draw our picture really quick. So let's get a rectangle going here. Well, a rectangle has a length.
You could just guess and check this one.
Like I said, there's ways to do this, but the one on the test is going to be harder than this. And when you get to calculus, we're going to have like volume problems and stuff, and you won't be able to just guess and check. So learn this method. All right, so we have length and width. Well, they give me a perimeter. So we're going to have to use that. Use whatever they give you to start off with. So that is 2 times L plus 2 times width equals my 100 meters. I'm also going to put over here that area equals length times width. But it says express the area as a function of width or length. You pick the variable. So what we're going to do is we're going to solve for one of these variables, and then we're going to be able to rewrite it and put it up over there. Let's pick width because that's the first one they said. So we're going to solve for width. So we're going to subtract 2L from both sides. So that'll be 2W equals 100 minus 2L. Divide both sides by 2 and you come up with W equals, I'm going to switch the placement of the L. So I'm going to do negative L plus 50. And since W equals that, you're just going to take that and plug that in for that W up there. So that's going to make our areas actually an equal length times negative length plus 50. Let's distribute that L. We're going to have A equals negative L squared plus 50 L. That's quadratic. I have L squared. It's just like X squared, but it's an L. It is L squared. So this is a quadratic. And not only is it quadratic, I have a negative A value, so it's a quadratic that opens down. Right at the top is my vertex, which is also my maximum. So to maximize this formula, we're just going to find the vertex. That is the maximum value we can get for our area. Anything less will be smaller. Anything to the right will be smaller as well. Our maximum area is right smack dab at that vertex. Now, when I'm looking for vertex, I'm thinking, well, x equals negative b over 2a. Yeah?
So in these problems, will we always be maximizing or minimizing something?
Yes. Yep.
Because
It's hard to say what's the exact medium level of, yeah, it's either maximizing or minimizing. All right, just remember our vertex has an x value of negative b over 2a. However, in this example, my L takes the place of my x value, and my A takes the place of my y value. In other words, L is my input, A is my output. So if we have a formula that says x equals negative b over 2a, we're going to use that formula. But instead of x, we're using L in its place. So L equals negative b over 2a, which is going to be negative. My b value is 50. So negative 50 over 2 times my a value is negative 1.
Oh, 2. Okay, I see.
Okay, yeah, 2 times negative 1, which is going to end up equaling 25. Well, that's just my length. My length is 25, which means my width equals, well, that's negative L plus 50. Plug that 25 in there. My width is going to also be 25.
It's a square.
So, yes,
I was like, why did you draw it kind of not that much rectangular?
because we don't know it.
Rectangle.
Yeah.
We don't know it. So our area is going to be 25 times 25, which equals 625. 625 meters squared. Yes?
So if it's a rectangular region, it could be a square.
It could be. A square is a rectangle. A square is also a rhombus.
Yeah, I know.
So it could say a rhombus.
It's also a polygon.
It is also a polygon. It's also
A circle.
a parallelogram.
That would be cruel.
Not a circle, but it is also a parallelogram because all the sides. So a square follows every rule of a parallelogram, a rectangle, and a rhombus. All in one superstructure. All right, questions on this? I want you to look real quick at the first maximization problem because squares are all good and dandy, except I didn't give you ones that are squares. So I want you to look at number 7. El siete.
Where does it start with B?
Yeah.
What happened?
It starts with the letter B. Oh, because 8 has A, B, C. Okay. Number 7 starts with the letter D.
Does it really?
It starts with A. Yeah, I was
Oh.
like, what's going on?
Oh, I think Word just
Yeah.
transposed my counting. Because I'm sure I had ABC Word do it, and then I probably put 7 in after, and it counted as
Yeah.
D. Anywho, it should be ABC. But in 7 it says, is this the farmer one?
Yes.
Yeah.
Okay. I think I have a different one than you.
120 meters.
102.
Oh, mine's 105.
Wait, what?
Yours is just staple.
Mine says 102. Or I'm dyslexic. But
That's not, no, you have a different, that's not what ours looks like at all.
that's what I got. Am I looking for my side? No, I got this one, and then I got this one.
Wait, 7, come on, 7.
Yeah, and then this one. Oh, I was talking
Oh,
about
okay, okay.
Okay, so number 7 should say, all right, a farmer wants to make a rectangular enclosure using a wall as one side and 120 meters of fencing for the other 3 sides, right? We're in the right one?
Yes.
Okay. So when you're drawing this one, this is kind of what we're talking about. There's already an existing wall. So I'm just going to use that wall. That doesn't factor into my equation at all. What I'm going to do is I want to take fencing. Let's go ahead and put what I'm adding in red, I guess. I'm adding fencing like this. Oh, that's a little angled. So I don't care about this. I'm only adding the fencing here. So we only have to worry about a width, and a length. So in this case, our perimeter would be 2W plus L. Just 1L, because I don't have 2 lengths of fencing to do. All right, so that's going to change those problems. So you're going to have to maximize them, and you can't just say it's a square. All right, the rest is your homework. Go ahead and get started. As always, like I said last time, you might want to start using your calculator to check your answers. Yeah. Okay, go. Okay, go. Yes. Wait till someone comes back, because that's 3 people.